Okay, so I've been making a little bit more progress with the AGC monitor. The wiring here has gotten a little bit out of hand, but there's still a few pins left open on the AGC's FPGA, so hopefully I'll have enough to get through the rest of it. Right now it's running Luminary 99, the Apollo 11 LEM rope, and I've added a lot more to this interface here. Almost all of the controls now are in place from the original monitor. We have in the top left here a box that controls writing into the W register, and just below the W register there is a box of switches for the W comparator. Then we have S1 and S2 comparators, and an I comparator, and then a bunch of stop conditions. And so right now I have the W register set up to look at the contents of Q. But all of these controls support fairly complex breakpointing. So as an example, let's say in T4rupt, I want to see what happens in these instructions when we get to this CCS and dsrep switch is 3. Dsrep switch counts, as this comment implies, from 7 down to 0 over and over and over again. And so the first step in doing this is to set up the W register to monitor dsrep switch. So I'm going to use my S2 comparator for that. dsrep switch is at address 1313. And so I'm going to set all of these ignore switches for the bank registers and the fixed extension channel because they don't matter for this erasable address. And then the address of the word is 1313. Okay, so our S2 comparator is set up. I'm now going to switch my W register over to G, where the memory words are buffered. Select S2 as the comparator to use, and then put it into S mode. And now we're watching dsrep switch, and we can see that it's counting from 7 down to 0 in a loop, as expected. So we said we want the contents of dsrep switch to be 3 when we hit the breakpoint, and so we use the W comparator for that. So I'm going to ignore the parity bits because I don't care about them, and I'm going to specify that W must be 3 for the breakpoint. And now the last step is to specify this CCS instruction as the one that I want to break on when dsrep switch is 3. So it's at address 06-2003. So I'll set that up in my S1 comparator. Again, I don't care about the erasable bank or the fixed extension channel. I do care about the F bank this time. We're in bank 6. And the address is 2003. Sorry, 2003. Alright, so S1 is set up now, and I'm going to use the S and W stop condition for this, which means that my W comparator must match, and because I have S1 selected, my S1 comparator must match S. So when I hit S and W here, we've stopped the computer. My W is 3, as I wanted. My Z is 2003, which is the address of the CCS. And so we caught it exactly where I wanted. So if I switch it over into NISC mode for single stepping instructions, I can proceed, and so now Z is 2004, we're actually on that CCS, and if I proceed again, dsrep switch has gone down to 2, which is, what you would expect a CCS to do to your number, and I can step through there. Another thing that you can do with this interface is break on particular instructions. And so let's say, let me start this guy running again. Let's say I want to break on a multiply instruction. I can do that using the I comparator here. So I'm going to set it up to break on the MP0 sub-instruction, so I don't care about the branch. I do care about the stage being 0, and then multiply is has the extend bit set, and then it is a 7 in SQ. Quarter codes don't matter for this, so we're going to ignore these bits. And then I'm going to set all of the status bits to ignore as well, because we just care about the instruction. And then I can set an I breakpoint, and there we go. We have caught a multiply instruction in action. And you can do, various combinations of these things. And for W, you can combine I comparison with S or P, which is almost the same as S. It just continues on to the next NISC. And you can combine, instead of, I did S and W earlier, you can do S and I instead for when an instruction hits a particular address. And yeah, so that's where it is right now. The next step is to make the box here that this proceed button actually belongs in. That box also does the manual loading and reading of memory through the 5 peripheral instructions.